All right, in this video I'm going to show you how to multiply and divide a power series. So I'm just going to give you two examples, one first with multiplication and then next with division. Okay, so we're going to find the first four terms of the Maclaurin series for e to the x over 1 minus x. So in this particular case, we actually know a power series for 1 over 1 minus x. So since multiplication is easier than division, I'm going to go ahead and use multiplication here. So we're going to do the power series for e to the x times the power series for 1 over 1 minus x. Okay, and so the power series for e to the x, I'll just, rather than write it in sigma notation, I'm going to write out the first few terms because that's all we're going to need. Okay, so we have 1 plus x squared over 2 plus x cubed over 3 factorial, etc., etc. Okay, if it turns out I need more terms than this to get the first four terms of this one, I'll just add more on later, but first I'm going to start with this. Okay, and then the power series for the Maclaurin series for 1 over 1 minus x is just 1 plus x squared plus x cubed, and so on. All right, so the way we do this is we basically expound out the way we normally multiply polynomials together. Okay, so we're going to have 1 times all of this. Okay, so 1 times 1 times x squared, 1 times x cubed. And then, of course, a lot of other terms when I multiply the 1 to everything that's left. Next, we'll take this x and distribute it to this power series. So plus x times 1 plus x times x, etc. And then I'm going to go with the x squared over 2 and distribute it. So we have x squared over 2 times 1, x squared over 2 times x, times x squared, etc., etc. Okay, and now finally we will take the x cubed over 3 factorial and distribute it out. So x cubed over 3 factorial times 1 plus x to the 4th over 3 factorial, etc., etc., etc. Again, experience tells me that I have more than enough terms here in order to get the first 4 terms of the Maclaurin series for this. But if in the end, after I collected like terms, I didn't have enough, I would just, keep adding terms on until I have enough. All right, so at this point, we're going to collect like terms. Okay, so we have 1, but there are no other constants here, so it's going to be 1. And then we need to collect the terms that are just to the power x to the power of 1. So we have here, we have 1 x to the power of 1, and we have another x to the power of 1. Okay, so we get 2x there. Then we want to do the x squared terms. So we have an x squared here, and x squared here, and an x squared here. Okay, and I know there are no x squareds coming from here. Okay, because that was starting off at x cubed over 3 factorial times that 1. So we have x squared plus x squared over 2. So that's going to be plus 5 halves x squared. And then last up, we need to take care of the x cubed. So here we can see we didn't need the x to the 4th. So we have an x cubed there, and x cubed there, and x cubed there, and finally an x cubed there. So if we add all those up together, so we have 1 plus 1 plus 1/2 plus 1/6, we're going to get 8/3. So plus 8/3 x cubed, etc., etc. Okay, so here are the first 4 terms of the Maclaurin series for e to the x over 1 minus x. All right, before dividing power series, I'm going to give you a quick reminder of how polynomial division works. So if I have x cubed plus x squared plus x plus 1 divided by x minus 1, I do it as follows. I say, what do I multiply by x to get x cubed, and that's x squared. So I would put the x squared up here. Some people would like to align it with the x squared over here, but I'm just going to go ahead and put it there. So when we take that x squared times this right here, times x minus 1, so we get x squared times x, and these guys should always cancel out. So minus x squared, and then we subtract. So x cubed minus x cubed is 0. X squared minus a minus x squared is going to be 2x squared. And then we say, okay, x times what is 2x squared? So that's going to be plus 2x. And then we'll bring down this x right here. Multiply 2x squared minus 2x times 1, so minus 2x. Subtract. So 2x squared minus 2x squared is 0. X minus a negative 2x is going to be 3x. Bring down the plus 1. So x times 3 is going to be 3x, so plus 3. And then we get 3x minus 3. So subtract, boom, and we have 3x minus 3x is 0, 1 minus negative 3 is 4. So our answer would be x squared plus 2x plus 3 plus the remainder 4 over x minus 1. Okay, so that's the way polynomial division works. All right, so now we will find the first 4 terms of the Maclaurin series for e to the x divided by cosine of x. So I could reduce this to e to the x times secant of x and use multiplication, but then I would need the power series for secant of x, which I don't readily have. Okay, so we're going to go ahead and actually divide the power series for cosine of x into the power series for e to the x. So the power series for cosine of x is going to be 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And I'll go ahead and stop there. We're going to divide that into the power series for e to the x. So 1 plus x squared over 2 plus x cubed over 3 factorial. And if I need to add terms on in the end, I will. Okay, so just like I showed you in the example a second ago, we have to say, okay, 1 times what gives us 1? And of course the answer to that is 1. So we put our 1 up here, and then we're going to multiply by all of this. Okay, and I'm going to put each term below the corresponding spot. So 1 times 1 is 1, and there's no x there, so plus 0x minus x squared over 2, then plus 0x cubed, and hopefully this is going to be enough, but then we would have plus x to the 4th over 4 factorial, okay, etc., etc., etc. So we'll just stop right there. Again, just use the first few terms when you multiply this to this. So we subtract. Okay, so 1 minus 1 is going to be 0. We have x minus 0x is just x. X squared over 2 minus a minus, so x squared over 2 plus x squared over 2 is just going to be x squared. And then x cubed over 3 factorial minus 0x cubed, so that's just going to be x cubed over 3 factorial. Okay, and again, we just want the first 4 terms, and this should be sufficient for us. Okay, so plus other stuff. That, again, I will only add on if I needed to later. All right, so now we do the next step. So 1 into x. So 1 times x is x. So x goes up here, multiply. Okay, so x times 1, x cubed over 2. Again, just carry out a few terms here. So we subtract. So x minus x is 0. X squared minus 0x squared is x squared. X cubed over 6 plus x cubed over 2. So x cubed, so 1/6 plus 1/2 will be 2/3. Okay, and now we just do it again. So 1 times x squared is x squared. we multiply. Again, we only want the first 4 terms, so we don't have to carry it out too far at each step. So x squared minus x squared is 0, then we get our 2/3 x cubed minus 0 x cubed, 2/3 x cubed, and I can already tell that this term here is not going to be 0, so I will not need the rest of this stuff. So 1 times 2/3 x cubed is going to be 2/3 x cubed. So we get 0 plus a bunch of other stuff, which is non-zero. Okay, so again, we only needed the first 4 terms of the series. So we have it right up here, so plus dot, 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 but this right here is going to be the first 4 terms of our Maclaurin series, okay? So that means that e to the x over cosine of x equals 1 plus x squared plus 2/3 x cubed plus a bunch of other stuff. Okay, so that's the way division of power series works.